Welcome to the Psychology and Physical Training channel, the importance of sampling size in research. Ever wondered why researchers pay so much attention to the size of their samples in their studies? Well, it's all about ensuring the accuracy and reliability of their findings. Let's start at the beginning. Sampling is a method used in research to draw conclusions about a larger population based on a smaller group or sample. It's like taking a small slice of pie to get an idea of how the whole pie tastes. But here's the thing, the size of that slice matters. Imagine you're trying to figure out the favorite flavor of ice cream in your city. If you only ask 5 people, you might end up with a skewed result. But if you ask 500 or even 5,000, you'll likely get a more accurate picture. This is the principle behind the importance of sample size in research. The size of the sample plays a crucial role in determining the accuracy of the research findings. The larger the sample size, the more closely it represents the entire population. This is because a larger sample size reduces the potential for error and increases the likelihood that the sample accurately reflects the population it's meant to represent. For instance, if a researcher is studying the effects of a new medication, a sample size of 50 patients might not be large enough to detect all potential side effects. But a sample size of 500 patients would provide a more accurate and reliable measure of the medication's effects. Sample size also affects the statistical power of a study. In simple terms, statistical power is the likelihood that a study will detect an effect when there is an effect there to be detected. A larger sample size increases statistical power, making it more likely that the study will accurately identify any effects. However, it's also important to note that larger sample sizes come with their own challenges, including increased costs and logistical complexities. So researchers must strike a balance between having a large enough sample to ensure accuracy and managing the practicalities of conducting the research. Remember, the size of the sample in a study can make or break the accuracy of the research results. So the next time you read a research study, don't forget to check the sample size. Breaking down the concept of sampling size. Now, you might be wondering, what exactly is this sampling size we keep talking about? Well, let's break it down. In the world of research, sampling size refers to the number of individuals or items selected from a larger population for a study. It's like choosing a handful of jelly beans from a large jar to get a sense of the overall flavor mix. Think of it this way. Imagine you're at a party with 100 people and you want to know what the average age is. Would you ask every single person there? Unlikely. You'd probably select a smaller group, say 20 people, and calculate the average age of that group. That group is your sample, and the number of people in it, 20 in this case, is your sampling size. But why not just ask everyone? Well, sometimes it's not feasible due to factors like time, cost, or accessibility. So researchers choose a sample that's representative of the whole. Now, how do researchers decide on the size of the sample? It's not as simple as picking a random number. The selection is based on the nature of the study and the target population. For instance, if you're researching a rare disease that only affects 1 in a million people, you might need a larger sample size to get significant results. On the other hand, if you're studying the preferences of people in a small town, a smaller sample might suffice. Keep in mind that the goal is to make a meaningful inference about the larger population. So, the sample size needs to be large enough to be representative, but not so large that it becomes impractical. It's a delicate balance. So the next time you come across the term sampling size in a research study, you know it's all about the number of individuals or items picked from the larger population for the study. Understanding sampling errors. Just as sampling size is important, so is the concept of sampling errors. But what are they, you might ask? Well, let's dive right in. When we talk about sampling errors, we're referring to the differences between the sample and the population that it represents. Imagine you're trying to find out the average height of all the students in a school. You might not have the time or resources to measure every single student, so you select a sample of students and measure them instead. If the average height of your sample differs from the average height of all the students in the school, that difference is a sampling error. In a perfect world, Your sample would be a perfect reflection of your population, but we don't live in a perfect world, do we? In reality, there will always be some degree of sampling error. This is because your sample, no matter how well chosen, will never perfectly replicate your entire population. Now, why does this matter? Think about it. If your sample isn't a good representation of your population, then your research results may not be accurate. That's like saying the average height of students in a school is 5 feet, when in reality it might be around 5 feet and 6 inches. This can lead to incorrect conclusions, which can be problematic, especially in fields like medicine or policymaking. But here's the thing about sampling errors: they're inevitable. No matter how careful you are, there's always a chance that your sample won't perfectly reflect your population. It's a bit like baking a cake. Even if you follow the recipe to the letter, there's always a chance that your cake won't turn out exactly like the picture in the cookbook. Sampling errors, as we see, can significantly alter the research results. They are like the unexpected guests at a party, often unwanted but always showing up. So as we move forward, let's discuss how we can mitigate these unexpected guests and ensure that our research is as accurate as possible. Mitigating sampling errors. So, we know sampling errors can be pesky, but can we do anything about them? Well, yes, we can. There are strategies to minimize sampling errors, and that's what we'll delve into now. First off, let's talk about the importance of a well-planned research design. A good research design is like the blueprint of a building. It guides your research process, ensures your study is valid, reliable, and can be replicated. It helps you specify your sampling method, the size of your sample, and how you'll collect and analyze your data. Now let's move on to proper sampling techniques. We've got a few options here. One is simple random sampling, where every member of your population has an equal chance of being selected. This helps to ensure that your sample is representative of your population, which in turn reduces sampling errors. Another technique is stratified sampling. Here you divide your population into smaller distinct groups or strata based on certain characteristics. Then you randomly select samples from each stratum. This technique can be highly effective if your population is diverse, and you want to ensure that all groups are adequately represented. The third technique is cluster sampling. This is similar to stratified sampling, but here you're dividing your population into clusters that are representative of the entire population. You then randomly select clusters and include all members of those clusters in your sample. This can be a handy technique if your population is widespread geographically. Lastly, let's talk about sample size. As a general rule, the larger your sample size, the lower your sampling error. But remember, larger sample sizes can also mean more time, resources, and effort. So, it's all about finding the right balance. In conclusion, while sampling errors are an inherent part of research, they can be mitigated. A well-planned research design, proper sampling techniques, and an appropriate sample size are your best weapons against sampling errors. While we can't eliminate sampling errors completely, we can certainly minimize their impact on our research results. So, keep these strategies in mind, and you'll be well on your way to conducting robust, reliable research. Key takeaways. So what have we learned today? Well, we've delved into the world of research methodology, specifically focusing on the significance of sampling size in research. We've realized that a well-chosen sample size is crucial to ensuring the reliability and accuracy of research findings. We also broke down the concept of sampling errors, understanding that these are discrepancies that can occur when a sample is not fully representative of the population. This can lead to skewed results and misinterpretations. However, we've seen that it's possible to mitigate these errors. By using proper selection methods, increasing sample size, and ensuring diversity, we can effectively reduce the likelihood of sampling errors. In the grand scheme of things, these concepts may seem minute, but they hold immense weight in the realm of research. Now, armed with this knowledge, you can better appreciate the intricacies of research methodology. Remember, the devil is in the details, or in this case, in the sample size and sampling errors. And if you like this video, do not forget to subscribe and follow the Psychology and Physical Training channel for more videos. Thank you for watching.